Good morning. It is Thursday, April 30th. So it is, oops, sorry about the wobble, the last day of the month. Today, what we're actually talking about, first we're going to talk about our unifying principle that physical forces affect the movement of all matter on Earth and throughout the universe. We are looking at work and energy. So energy is transferred when a force moves an object. And then for today, what we're going to be discussing is power is the rate at which work is done. Power can be calculated from work and time, and power can be calculated from energy and time. So we have two different ways of going about determining and calculating power. So looking at power can be calculated from work and time. Power is the rate at which work is done. All right, so the definition of power is the rate at which work is done, the work you do. Looking at vocabulary today, power, watt, and horsepower. So the word power has a lot of different common meanings. It's used to mean a source of energy, such as a power plant, as a strength, as in a powerful engine. We can talk about being a powerful swimmer. You can say a swimmer is very strong, very fast, but powerful is one who does the work of moving oneself through the water over a short period of time. All right? So we calculate power from work. So when we're looking at calculating power from work, the formula is power equals work divided by time. So P equals W with a capital W divided by time with a lowercase. Work is measured in joules, however, power is measured in watts. So work is joule, power is watts. And again, for the question for yesterday or the Monday, a lot of you lost points because you were not using your units. We talked about that in the lecture. I made sure that that was part of the question, making sure that you were putting your answer with units. That's a very hard and fast mathematical and scientific principle for when we're using calculations and formulas. So you have to make sure that you are talking about the units, okay? The next thing, so with a sample problem, I could say an Antarctic explorer uses 6,000 joules of work to pull his sled for 60 seconds. What power does he need? Well, we would take 6,000 joules and divide that by 60 seconds. And what we would end up with is 100 joules per second, or 100 watts. So we talked about Newton meters being joules. Joules in seconds, again, that definition for power is watts. We also talk about horsepower, and James Watt was a Scottish engineer for whom the watt is named, improved the power of the steam engine in the mid-1700s. Watt also developed a unit of measurement for power called horsepower. Now, horsepower is based on exactly what it sounds like, the amount of work a horse can do in a minute. In Watt's time, the 1700s, people used horses to do many different types of work. For example, horses were used on farms to pull plows and wagons. So that was something that people understood. That was a commonality, and therefore the word horsepower was developed, and to this day we still use horsepower when we talk about usually cars, boats, trucks, that sort of thing. We talk about the number of horsepower that something has for pulling. All right, so we can also calculate power from energy and time. So that was work and time. So when we're using energy, power is equal to energy divided by time. So as long as you have the amount of energy or the amount of work that's done, you can use either of those to calculate power. So since you may know that energy is being transferred and you cannot directly measure the work done by force involved, you can then use energy, the amount of energy that's involved. And that's the reason that we've got two different calculations for that, is that you may not actually know or you may not actually have direct access to the amount of work, the measurement for the amount of work. So one of the things that we want to talk about now is everyday power, because in everyday power, when we talk about power, this is where we come a lot into the whole concept of types of fuel, for example. So we've got nuclear, we have electric in the houses. We have solar, we have wind power, we have hydroelectric power. When we're talking about power, this relates a lot to the actual way that we fuel things in our everyday lives. So when you're plugging in a hairdryer and a switch is turned on, we've got electrical energy as electrons are moving along those wires. Agitated electrons are moving along those wires, creating that electricity. So tomorrow, even though we have a test tomorrow, there's going to be a lecture and some work as well on fuel sources, types of fuels, renewable, non-renewable. We will have one discussion question related to that. That is actually a core knowledge concept for this year. I know that in the past, when you've studied, you've learned about things like nuclear power and electricity, things like that. It's really important that we go back over that again so that we're understanding which of those are renewable and non-renewable. And you're also going to have a video that talks about the pros and cons of each, because we know that fossil fuels were an early source of energy. As a world, we're highly dependent upon fossil fuels, but at the same time, we also have some cons related to them in that they are a pollutant. So we have a lot of negatives that go with that. Same thing with nuclear power. We're going to go over a couple of types of disasters that have occurred as a result of nuclear powers. We've got Chernobyl, 3 Mile Island, and other things that have happened as a result of that. All right, so that's pretty much it, what we have here for today in terms of talking about power. So I want to go back to that concept that we talked about early in, hold on, the dog's eating my plant. Montana, get away from there. So talking about the way that we have these subtle nuances between words like work, power, force, friction, energy, conductive, convection, radiation, how they're transferred, how they're transformed. So we're going to spend a little bit more time at the beginning of next week and as we go on talking about that. All right, so that will be it for today. Just remember that power is the rate at which we do work, and how horsepower is based on the unit of work that a horse could do in 1 hour, or 1 minute, the watt, okay? Remember, I'm at school today from about 9:30 to noon, so if you want to stop in, you have some questions, want some one-on-one help, I'll be there. At 10 o'clock, I will be on our normal Zoom call. I'll post those details. The other thing I want to remind you of is that you should have posted this morning the reading of the entire chapter that I have used for talking about work, energy, and power. So if you want to listen to that chapter being read aloud to you, you'll recognize some of the examples that I've used, and you will also get detailed descriptions and things like that. All right? Have a wonderful day. See you at office hours. Bye.